It doesn't have any multiplication, addition, subtraction, nothing. So this is actually already set up to solve for the kinetic energy. Great. So if you're doing any problems where you have to solve for kinetic energy, this is the form you want your equation to have. Now let's walk through if we wanted to solve for mass, okay? So currently mass is in the numerator, but it's not by itself. So if it's in the numerator, we're going to leave it alone. But we're going to work on getting everything else away from it, okay? So for starters, let's work with the fraction, because we always know if you're trying to get a fraction off of the same side as something, multiply by the reciprocal, okay? So the reciprocal of 1 over 2 is going to be 2 over 1. All right? So KE times 2, because that's in the numerator, that's in the numerator. That gives us 2KE. Now this 1 is in the denominator, but anything divided by 1 is itself. So we don't really need to write that 1. Okay? So now that is going to equal mv squared, right? Because this 2 in the numerator cancels out with that 2 in the denominator. And then that 1 and that 1, again, cancel out. Okay? So now I have 2ke equals mv squared. I need to get m by itself. Okay? So in order to do that, I don't need to take a square root or anything like that. The only time I would take a square root is if the variable I'm interested in is currently being squared. V is being squared, but I'm not interested in V, so I don't have to take a square root to get V by itself. M is being multiplied by V squared. So in order to get V squared away from M, I need to do the opposite of multiplication. So I'm going to divide by V squared on both sides. So that gives me 2ke over V squared equals M. Great. All right. So my V squareds cancel out and I'm just left with M in the numerator. All right. Now let's quickly look at the units and how that plays a role. So my kinetic energy is in a unit of joules. And I know joules is equal to a kilogram times, actually let me write it below. A joule is equal to a kilogram times meter squared over second squared. All right. And then velocity, my velocity is V squared. So velocity is in meters per second, but when I square it, it's meters squared over second squared. And I can see from my units being set up, if I break my joules apart, when I set up my units, my meter squared over second squared will cancel out, and I'll be left with kilograms. And kilograms is indeed the unit of mass. All right? So that's how your units will work out. All right? But that's the form of the equation you want to use if you're solving for mass. Now let's go ahead and solve for velocity. Okay? So we can actually keep this first part just like we had before, because we still need to get that 1/2 off of this side. All right. But now instead of dividing by V squared, we want V squared. So we need to get everything else away from V squared. Okay. So we're going to divide by M on both sides. That's going to give us 2ke over M equals V squared. Okay. Now, remember, I'm interested in V by itself. So in order to get V by itself, it is currently being squared. So I need to square root it to get V alone. So I'm going to square root both sides. And I end up with 2ke over M, all under the square root sign, equals V. All right. So all of that is good to go. Now, let's walk through our unit analysis. So if I substitute in joules, right? If I substitute in the alternative definition of joules, I'll end up with kilogram. If you all can see this, I don't know if you can see this. So I'm going to write it. I'm going to erase all this. I'm going to write 2ke over m square root is equal to v. All right. So if I substitute in my units, I get kilograms times meters squared over seconds squared up top. And then mass is in kilograms down low. All right. Now, the reason I don't write the 2 is because I'm just dealing with unit analysis right now. 2 has no units. All right. So I would do all of my number stuff and then all of my unit stuff.